So let's look at the integration method trig sub. So if you have any of these three integrals, or if you have something in your integral where a part of it looks like this, if it looks either like square root a squared minus x squared, square root a squared plus x squared, or square root x squared minus a squared, where a is just just a number, just a constant, not a variable, then you can use one of these three trig subs. If it looks like this, where it's square root a squared minus x squared dx, then you can use a trig sub x equals a sine theta. If it looks like square root a squared plus x squared, then you can use x equals a tan theta. If it looks like square root of x squared minus a squared, then you can use the trig sub x equals a secant theta. So these are the three common trig subs, and we're going to do some problems with them. Okay, let's look at question 1. We have the integral of square root 4 minus x squared divided by x squared dx. So if we look back at our trig subs, this looks like a squared minus x squared. So we can use the trig sub x equals a sine theta. And to find a, we have a squared. A squared is equal to 4. So if we square root both sides, we'll have a equals 2 and x equals 2 sine theta. Now, since we're using a new variable, since we're using theta in our integral, we're going to have to integrate x to get dx equal to, so if we just, not integrate, we have to differentiate x to get dx equals 2 cosine theta, d theta. Since we're integrating with respect to x, this is going to be d theta. Now let's also solve for theta as well, because we're going to have to use it later on. So if we solve for theta, it's going to be arc sine x over 2. Now let's actually plug everything into the integral and see what we can get to. So this can be the integral of 4 minus x squared. So we have x. So if we square both sides, it's going to be 4 sine squared theta divided by x squared again is just going to be the same thing, 4 sine squared theta. And dx, we said that's equal to 2 cosine theta d theta, 2 cosine theta d theta. And here, this is going to be equal to square root 4 times 1 minus sine squared theta, 4 sine squared theta, 2 cosine theta d theta. And we can bring this 4 out and it'll become a 2 because the square root of 4 is just 2. So this will be 2 square root 1 minus sine squared theta divided by 4 sine squared theta, 2 cosine theta d theta. Now if we multiply 2 and 2 over here, we'll get 4, and 4 divided by 4 is just 1, so we can cancel off all the scalar multipliers. And if you notice here, 1 minus sine squared is the same as cosine squared, and the square root of cosine squared is just cosine. So we can simplify this whole thing down to, and cosine multiplied by cosine is cosine squared theta divided by sine squared theta d theta. Now this is a lot easier to integrate because, let's go over here, because this is actually the same as, if we can split this integral if we write cosine squared theta as 1 minus sine squared theta divided by sine squared theta d theta. Now we can split this apart and we now can have 1 over sine squared theta minus d theta, because sine squared over sine squared is just 1. So technically we're just integrating 1, which is the integral of d theta. Now this is going to equal cosecant squared theta minus theta, because the integral of 1 is just theta. Now over here, so if you look at the derivative of cotangent theta, it's going to equal negative cosecant squared theta. But since we're looking at positive, the cotangent has to be negative. So this is just going to equal negative cotangent theta minus theta plus c. But this is not our final answer because we have our answer in terms of theta and our original function is in terms of x. So we have to figure out how to make this equal to x. So first of all, theta we said is just equal to arc sine. So we don't have to do anything with this. We'll rewrite it later. But here is where we need to draw a triangle. So if we draw a triangle over here. Now, arc sine x over 2. Sine is opposite over hypotenuse. So opposite is x. And the hypotenuse is 2. And this side is just going to be 4 minus x squared. And we need to solve for cotangent. So cotangent is adjacent over opposite. So adjacent over opposite is going to equal negative square root 4 minus x squared divided by x minus theta is equal to arc sine x over 2 plus c. And this is our final answer. Question 2, we have the integral of square root x squared minus 4 divided by x dx. So this looks very similar to the last one we just did, but the main difference is that instead of a squared minus x squared, it's x squared minus a squared. So we're going to use a different trig sub. So we're going to use x equals a secant theta, and to find a, we have a squared equals 4, so a is equal to 2. So x equals 2 secant theta, and we need to find the derivative of x, so dx is equal to 2 secant theta tan theta d theta. And let's solve for theta, which is equal to arc secant x over 2, and let's also draw the triangle. So cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. So this is x2, so this is going to be x squared minus 4. Okay, now let's substitute everything we have into the integral. So this is going to be the integral of square root. X squared is going to be 4 secant squared theta minus 4 divided by x, which is just 2 secant theta. So 2 secant theta. And dx is 2 secant theta tan theta d theta. Now we can cut off the 2 and the secant theta. And let's simplify the numerator a little bit. So we can bring this 4 out, and this is going to be 2 secant squared theta minus 1 tan theta d theta. Now secant squared theta minus 1 is the same as tan squared theta, and the square root of tan squared is just tan. So this is going to be 2 tan theta d theta. So we can simplify this to be 2 tan squared theta d theta. And tangent, and actually first let's move this 2 outside. So we have 2 integral, tan is just sine over cosine, so tan squared is sine squared theta over cosine squared theta d theta. And once again, like the same thing we did last time, sine squared theta can be rewritten as 1 minus cosine squared theta divided by cosine squared theta d theta. And again, we can split this integral apart. So let's go over here. So we have 1 over cosine squared is secant squared theta minus cosine squared theta over cosine squared theta is just 1. So minus 2 integral d theta. Now, the integral of secant squared theta is just tangent. So 2 tangent theta minus 2 theta plus c. And again, we have our answer in terms of theta, but we need to figure out in terms of x because that's what we started with. So we already have our triangle constructed. So from here, we need to just find what tangent is. So tangent is opposite over adjacent. So it's going to be square root x squared minus 4 over 2. So 2 multiplied by square root x squared minus 4 divided by 2 minus 2. And we said theta is arc secant x over 2. Arc secant x over 2 plus c. And this 2 can get off, then can get cut off and cut off. So we're just left with x squared minus 4 minus 2 arc secant x over 2 plus c. And this is going to be our final answer. Question 3, we have 1 over x times x squared plus 16 dx. So here, this looks like arctan. Even though we don't have a square root, we can still do it. So for arctan, we don't need to have a square root. We can still do it with the square root, but it's still fine. So this is going to be x equals a tan theta. A squared is 16. A is equal to 4. So x equals 4 tan theta. Dx is equal to 4 secant squared theta d theta. And theta is equal to arctan x over 4. Let's draw the triangle as well. So tan is opposite over adjacent, so x 4. So this is going to be x squared plus 16. Now let's substitute everything into the integral. So this is going to be 1 over x is 4 tan theta multiplied by 16 tan squared theta plus 16. And then dx is just 4 secant squared theta, so multiply by 4 secant squared theta d theta. And then we can divide this 4. So we are just going to have secant squared theta d theta divided by 16 tan theta. And since we took out 16, tan squared theta plus 1 is the same as secant squared theta. So we can divide secant squared theta on the top and bottom. So we're just left with, if we take out the 16, we're going to have 1 over 16 integral 1 over tan theta d theta, which is the same thing as 1 over 16 integral of cotangent theta d theta. And cotangent is the reciprocal of tangent. So this is going to be cosine over sine. So 1 over 16 integral cosine theta over sine theta d theta. Now let's go back up here. So now we're actually going to have to use a u sub along with the trig sub. So we're going to set u equal to be sine theta. Du is equal to cosine theta d theta. And we're going to solve for d theta, which is du over cosine theta. And now let's plug it back into the integral. So we have 1 over 16 cosine theta over u du over cosine theta. So this both gets cancelled off, and we're left with 1 over 16, the integral of 1 over u du, which is equal to oh, this is divided by 1 divided by 16. So 1 over 16 ln absolute value u plus c. Now, since we started with x, we have to go back to x. So from u, we have to go to theta to x. So first, this is going to be 1 over 16 ln, and u we set was sine theta. So sine theta plus c. And sine theta, if we look over here, sine is opposite over hypotenuse. So x opposite over square root x squared plus 16. So this is going to be 1 over 16 ln. This is going to be x divided by square root x squared plus 16 plus c. And this is our final answer.